This little drone is about to take off, and the only thing keeping it in the air is code that you wrote. No remote, no pilot, no expensive electronics, just about $80 of parts, a phone, and a few lines of Python. In the next 10 minutes, we're going to build one together. From a box of parts to a drone that arms itself, lifts off, holds a perfect hover, and lands all on your command. Let's go. Here's the whole brain of the machine. It's a board called Lightwing, and at its center is a chip you might already recognize, the ESP-32S3. It's the same low-cost Wi-Fi chip that runs smart plugs and hobby projects everywhere. And here it's doing the full job of a flight controller. It reads the motion sensors, runs the stabilization loop, and talks to your phone and your laptop over Wi-Fi. One $5 chip is the entire autopilot. So what do you actually need, and what does it cost? The star is a board called Lightwing. It comes pre-soldered and on Amazon runs about $70. But it ships without a battery, so add one small lithium battery for around $10. Call it $80 all in. I've put the exact links in the description below. That's really the whole shopping list. The board, a battery, and the little motors and propellers that come with it. No soldering iron, no 3D printer. Add a phone you already own and a laptop, and you've got everything. First, lay everything out so nothing goes missing. Open the box and you'll find the main board, 4 motors with tiny colored wires, 4 propellers, the frame with its arms and landing legs, and the battery. Take a second to match each part to this picture. The motors come in 2 types and the props come in 2 types too, and telling them apart now is what makes the build go smoothly later. Sort them into 2 little piles and we're ready. Start with the frame. This is the plastic skeleton the whole drone hangs on. It has 4 arms reaching out, 1 motor at the end of each, and short legs underneath so it sits level and takes off cleanly. Snap the landing legs into place first, then set the frame down flat. Everything from here builds onto this base, so make sure the arms are even and nothing is cracked. A straight frame is a stable drone. A twisted one fights you in the air. Now the motors, 1 at the end of each arm. Press each motor firmly into its mount so it seats flat, then route the 2 thin wires back toward the board and plug them into their connector. Here's the detail that matters. The motors come in 2 kinds and they alternate around the frame. Diagonal motors match. Neighbors are opposites. If you follow the little diagram printed on the board, the colors line up on their own. Seat all 4, tuck the wires, and the drivetrain is done. Propellers next, and this is the single step people get wrong. A quadcopter doesn't spin all 4 props the same way. 2 spin clockwise, 2 spin counterclockwise, and they sit on the diagonals so the drone doesn't spin itself in circles. The props are marked, usually A and B. Match each prop to the motor turning that direction. Push it straight down onto the shaft and press until it clicks. Get this pattern right and it flies. Get it backwards and it flips the instant you touch the throttle. Time to give it power. This is a single-cell lithium battery, small and light, and it clips onto the top of the frame with the connector facing the board. Plug it in and it snaps home with a firm little click. 2 quick safety habits from the start. Only charge it with the charger it came with and unplug it whenever you're not flying. Treat the battery with respect and it'll give you dozens of flights on a charge that takes minutes. Before anything flies, a bench test. Take the props back off for this, keep your fingers clear, and power it on. A status light should come up steady, telling you the board is alive and the sensors pass their self-check. Now, with no props, nudge the throttle just a hair in the app and watch each motor. Everyone should spin, and each should turn the direction its diagram says. If one's dead or backwards, you fix it now, on the bench, not 2 feet in the air. The kit ships preloaded, but let's do the flash ourselves, because the moment you can put your own firmware on the board, it stops being a toy. Plug the drone into your laptop with a USB cable. Install the flashing tool with 1 pip command, grab the open source ESP-Drone firmware, and run the flash command pointing at the board's port. You'll watch a progress bar wipe the chip and write the new code. 30 seconds later, it reboots, and the flight brain is now software you control. Now pair your phone. The drone broadcasts its own Wi-Fi network, so open your phone's Wi-Fi settings and connect to the drone's name. No internet, no account, just a direct link between the two. Open the flight app and it finds the drone automatically. Do one quick thing first, set it on a flat surface and level the sensors. A 2-second calibration that tells the drone which way is up. A green light in the app means you're connected and ready. The payoff: props back on, battery charged, phone connected, and some clear space around you. Ease the throttle up slowly, and the drone lifts off your table and hovers. It'll drift a little at first. That's completely normal. Just nudge the trim until it holds its spot. That's your phone acting as the remote, sending your throttle over Wi-Fi, while the board does the hard work of staying level 50 times a second. You just flew a drone you built with your own hands. You've flown it, so now let's earn the how. A quadcopter has 4 motors and no moving flaps, so it steers by doing just one thing, changing how fast each motor spins. Speed all 4 up together and it climbs. Ease off the 2 on one side and it leans and slides that way. Speed up one diagonal while slowing the other and it pivots in place. Every move you make is really the board choosing 4 numbers, 4 motor speeds, many times a second. So what turns your command into those 4 numbers? The firmware. 50 times a second, the board reads its motion sensor, compares where the drone is actually tilted to where you asked it to be, and calculates the correction. That's a control loop, often called a PID loop. It feeds the answer into a mixer that sets each motor's exact speed. This tight little cycle, sense, compare, correct, mix, is the entire reason the drone feels stable instead of tumbling out of the sky. Here's where a toy becomes a robot. On your laptop, install a small open-source Python library called cflib. Again, just one pip command. It speaks the same radio language the drone already understands, so your computer can now send commands straight to the flight board. Connect to the drone's link, and you have a live programmable channel to the machine. From this point on, anything you can write in Python, the drone can do. And the script is shorter than you'd think. Open the link to the drone, send the command to arm, and take off to 1 meter. Tell it to hold there for 5 seconds, then command it to descend and land. Close the link. That's the whole flight. Just a handful of readable lines. No trigonometry, no motor math, because the firmware you flashed is handling all of that underneath. You're writing intentions, and the drone is turning them into flight. Now run it and watch. The drone arms itself, lifts to exactly 1 meter, holds dead still for 5 seconds, and sets itself back down, and you never touch the controls. That's the whole point. The same machine you flew by hand a minute ago just executed a plan you wrote, precisely, repeatably, hands off. Change one number, and it hovers higher. Add a loop, and it flies a square. This is the door from remote control toy to actual robotics. And you're only at the doorway. Because it's all just Python now, the drone will do whatever you can describe. Chain waypoints together and it flies a path. Read its battery and sensors mid-flight and it can react. Add a small camera or a distance sensor and it can start to see. The same $80 board that just hovered on your desk is the same class of computer that flies real autonomous research drones. The ceiling here is your imagination, not your budget. So look at what you did. About $80 of parts, snapped together part by part, flashed with open firmware, flown from your phone, and then flown entirely by your own code. You learned how a quadcopter actually steers, what the flight loop really does, and how a few lines of Python turn a toy into a robot. If that made it click, hit subscribe. A fresh teardown drops every single day.